So from the homework last night, if I was going to try to improve on things that I need to improve on, if I'm not great at factoring or there's old skills that Mr. Martin is going over, I would make notes to myself so that I can review and I start to see why he's factoring the way he does. So when I look back at my notes, I understand, oh, this is an example of perfect squares. Or, oh, this is an example of greatest common factor. So here's what I would do. We said the first thing we're going to do with this guy is a greatest common factor. So all Mr. Martin is going to write on his paper is this. Scratch that. Dyslexic for a second. It happens. Now that's all I'm going to write. Now what could you do to help yourself out if you struggle with factoring? Write a little note next to what I did that says how I did that. So you understand, this is an example of how to do a GCF. And you go back tonight and you can look at how you do a GCF. Why did he pull a 3 out? Because 3 went into all these things. How come he got a 2x squared? Because 3 times 2x squared gets you back to that 6x cubed that you needed. And you can review and go over that so you don't make mistakes on GCF. You have an example of what it looks like. You could even make up examples based off of this. Let me tell you what. If you can make up an example of GCF, you understand the concept now of GCF. With me? Now, is this a perfect square? No. 2 is not a perfect square. Is it a difference of squares problem? No. Is A 1? No. Crap. I'm okay with that. Because I realize I have to multiply 2 times 4, and this is the longer way of factoring. It's not harder, just it takes a little bit more time. 2 times 4 is 8. I need 2 numbers that multiply to 8, but different signs are going to subtract to 7. Well, those 2 numbers are 8 and 1, right? And they're different signs. Which one is going to be the bigger number? The bigger number is going to be negative. Are you following with where I'm getting all this stuff from? So I write this down. 2x squared. Now I could put the 1 first, or I could put the 8 first, and I told you what I would always do. If I have a choice, I always put the negative 1 first. It will make my second bubble much easier to deal with. Could I put the negative second if I wanted to? Yes. It's just going to make my factoring a little more tricky. So if I have a choice, I would always put it first. So I would go minus 8x plus x minus 4. Everybody okay with that? Is this still the same as this? Do I have a 2x squared? Yes. Do I have a negative 7x? What happens when I combine these two? What does that turn to? Negative 7x, right? And negative 4 is still there. So yes, I have still the same thing. I've just changed the way it looks. This is going to help me out when I go to factoring. Everybody following? If you can't tell, I'm trying to go over some old stuff so we can pick this up. 3x. Well, what do these guys, bubble these together? Bubble these together. What do these guys have in common? 2x. What am I left with? X minus 4. Plus, what do these guys have in common? Do they have anything in common? No, so there is no greatest common factor, but that's okay because what's left in my bubble? What was in this bubble? And what's in this bubble? Isn't that what I want to happen? So I'm left 3x. What does this have in common with this? So I factor out an x minus 4. Here's another tricky part. What am I left with? What is left here? What is left here? A plus 1. Do not forget that plus 1 there. Do you see right here? It's like me saying I have x minus 4 times 2x. Isn't that right here? And doesn't this say x minus 4 times 1? Isn't that what's right here? You following me? And this has to be greater than 0. Now the whole reason I needed to factor this is so I could graph this guy. In order to graph it, what do I need? The roots. So is this when I write x equals, is that my answer to this question? Those are my what that I'm just putting down. So you know what, let's not even put x equals. Let's just write x-intercepts. That way we don't get it confused. X-intercepts. What are my x-intercepts? You skipped one. What am I making each one of these bubbles? Okay, how do I make 3x? Can I make 3x 0? Yes, if x is what? So 0 is one of my roots. 4 is one of my roots because this is its own bubble, so that's 0. Put a 4 in here, it makes it 0. What one here? If I can't figure it out, what do I do? So I can take 2x plus 1 and set it equal to 0. Minus 1, 2x equals negative 1. Divide by 2. Hopefully you realize it's a negative 1/2. Eventually you're going to start to be able to do that in your head to where you won't have to do all that work. But if you need to, that's available still. You can do that, no problem. Is everybody with me? Now I look at this thing over here, and I see I see the way that they numbered it. Do I have to stick with the way they numbered it? No. In fact, you know what I'm going to do? I'm going to change it because I don't like the way that it's numbered. Because do you see how I have to graph a 1/2, and I also have to grab a 0? If I try to do that, what happens on my graph? It's really hard to see, isn't it? So you know what I'm going to do? I'm going to say, forget you, book. I don't care what you say. I'm making that a negative 1. And I'm making that a negative 2. I'm making that a negative 3. And I'm going to change these counting numbers because I have the power to do that. It's my graph, not yours. Back up off of me, book. Now the reason I did that is because now when I graph a half, do you see that the half is actually this number line, right? What am I counting by on my x's now? I'm counting by halves. Counting by halves, because look, I skipped 1 and then 1. Skip 1 and then 2. Right? So it's counting by halves. So that first mark is a negative 1/2. Graph 0 on there, and I also can graph 4 on there. Is everybody okay with my graph, my dots that I just put on there? Any questions with what I've done so far? Yes?
The way how you
Alright, so does everybody understand where I got the roots from?
Yes.
Now my next thing I need to do is from chapter 3. From chapter 3, I look at this 6x cubed. And I decide that it's positive and what? Which means odd, right? Positive and odd. The reason I need to decide that is I realize that this thing starts down and ends up. Do I care how high this hoop goes? Do I care how low this hoop goes? Especially for this problem. Because I'm comparing it to 0, I just want to know, is it above it or is it below it? It doesn't matter. Is 0.11 higher than 0? Is 100 higher than 0? Do I really care if it's just a little bit higher or if it's really high above it for this question? All I want is I want an x that when I plug it in, it's greater than 0. It could be 0.000001. As long as it's bigger than 0, that's all I care about. That would be a good x to answer my question that I have here. Because again, I'm picking x's that when I plug them in, when I solve all this together, when I multiply everything out, it gets me a number bigger than 0. You with me? No, don't worry about that. Don't worry about that. So right here are these values right here. So this section right here. Are these values greater than 0? Remember, this is x values, right? There are x values and there are y values. Well, when I put this x in, what kind of y value pops out? A negative. When I put this x value in, what kind of y pops out? When I put the x in, what y value do I want to pop? What do I want to pop out? So is this section over here going to work?
No.
So this is a no good section for what they're asking. Does that make sense? Is this section right here a good section? Why? Because when I put those x's in, what does my y value pop out? A positive, which is greater than 0. Is this section a good section? No, because my y values are negative. Is this section a good section? Are you guys following me with how to do this? Yes? So my answer should have been negative 1. So I would say that negative 1 is less than x, which is less than 0. If you took any x's in this section and you put it into this equation down here, what do you know about your value? It's going to be positive. Or, what's the other scenario that can happen? X has to be what? Greater than 4. Now, can it be equal to 4? Can it be equal to 4?
No.
No, because this starts out being it has to be greater than, so it's not allowed to be equal to.
Yeah, your sign was not.
Oh, sorry about that. Thank you. X is greater than 4. I'm saying it right, not doing it. All right. Questions on that? Let's roll to this guy. If I was doing this one, what's the first thing I'd want to check again? This is something that you could write on your own paper. He checked for what? Okay, check for GCF. There is no GCF. What's the next thing I'm going to check for? Is this a candidate for a perfect square?
Yes.
Does this have a square root? What is it? X squared. Does this have a square root? Oh crap. Is this a plus sign? We have a really good candidate for perfect square, guys. But when I multiply this times this and I double it, does that get me to what I need there?
No.
It gets me to only a 12x. Is it really close? Yes. Is it a perfect square though?
No.
Does everybody understand that? We good with that? So I go, okay, how come I can double bubble right away? A equals 1. This is going to be an x squared, and this is going to be an x squared. This says same sign, so I'm going to add. This says both of them are negative. Everybody okay with how I set that up? Two numbers that multiply to 36, but add to a 13, because they're same signs. 9 and 4. What popped up right here? Difference of squares. What popped up right here? X minus 2, x plus 2, x minus 3, x plus 3. Greater than 0. Oh, how about I look at the question? Less than or equal to 0. Less than or equal to 0. Change it up on me. Now, what do I need? My x-intercept, so I can graph this sucker. Intercept is 2, negative 2, 3, negative 3. So, negative 3, negative 2, 2, 3. It's even, and it's positive, so I know it's going to start up and end up. Looks like a funky W. Better be careful, we start getting all the letters up here. I might have to make you make your name out of equations. We could do some, project-based learning. All right, so what happens right here? is I want, where is this less than 0? Are these outputs less than 0? No, because my y's are positive, right? Is this section good? Yes. Is this section good? Is this section good? Is this section good? Now, please do not make up rules in your head, because I'm telling you, I have tutored kids, and kids make up rules all the time in their head. They start seeing one little pattern, and they make rules about all of math because of it. So they go, wait, do you see how it's not good, good, not good, good, not good? And they make that a rule. Is that for sure how that has to happen? Have we had graphs like this? Starts down, goes up, starts to go back down, but ends back up and goes like this. Have we had graphs where it just touches and goes right back up? Okay? Now, if I'm talking about where my y values are greater than 0, would this section be good? Would this section be good? Would this section be good? Would the next section be good right after it? So is it always yes, no, yes, no? No, you can have scenarios like that. So please don't make up rules in your head. I'm telling you, it's unbelievable the rules that I've heard in math. Does everybody understand this question now? So your inequality should be -2 is less than, or what this time though? Sorry. Yeah. -2 is less than or equal to x. Yep. -3 is less than or equal to x, which is less than or equal to -2. And then this one is or 2 is less than or equal to x, which is less than or equal to 3. Those would be my answers. Now, someone in first period asked a really good question. And yes, you should probably know this just in case I ask it on a test. They said, Mr. Martin, how would you do it, not graphically, how would you do it algebraically? I would probably not give this one on a test like this because first off, the numbers that you have to use are kind of nasty. And second off, there's 5 different sections that I have to test. You see my sections. 1, 2, 3, 1, 2, 3, 4, 5. Do you guys see the sections? Well, if I was writing that out and I was asking you to solve this algebraically, not graphically, do you guys see the difference? You would have to make kind of like a number line for yourself. And do you see your roots? They would still go in your number line. So it would be -3, -2, 2, and 3. Do you see? This is a section right here. This is a section. This is a section. This is a section. And this is a section. Do you get what I'm talking about? And if you look, aren't those the same sections that were over there? Right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those match up together. Are you with me? If you did it algebraically, what did she do when she did it algebraically? She picked a number that fit in the section. She plugged it into the equation and she said, does it make the equation true or does it make it false? If that one number made the equation true, the whole section was true. If that one number made it false, the whole section was false. So meaning, -4. She would plug in a -4. Are you with me? -4 minus 2 is a what? -6. Just watch what I do. -4 plus a 2 is a -2. -4 minus 3 is a -7. And -4 plus 3 is a... Now, if I am comparing this to 0, do I really care what number is on this side? What do I only care? If it's positive or if it's... Because all positive numbers are going to be bigger than 0. Is that good for what I need to happen here? No. What kind of number do I want to end up over on this side? A negative, because all negative numbers are smaller than 0. Are you with me? Negative and a negative make a. Negative and a positive and a negative make a. And a negative and a positive, or negative and a negative make a. So is this section good? because I end up with a positive number which is bigger than 0. This section is not good. Isn't that what we found out? And weren't our outputs all positive in that section over there? Now, what number would I have to choose here? A negative 2.5. Well, again, start over. Negative 2.5. Negative 2.5. And a negative 2 is a negative number. Negative 2.5 and a positive 2 is still a negative. Negative and a negative. Negative 2.5 and a negative 3 is still a negative number. But a negative 2 plus 3 ends up being what? Do you see how this becomes positive, this becomes negative, and it stays negative? So what kind of number does this section yield out? A negative number. Is that good? Is a negative number less than 0? Yes. So this section is good. Is that what we found out over here also? So do you see on algebraically how you're supposed to do it? Do you see the difference? Yes, ma'am. Yes, because remember, remember over here how I had to check those sections each. So you're not, it could be more than one section. Could all these sections actually be true? Sure. Maybe it's all numbers. Maybe all of them work out. So yes, you have to check it all. Good question. All right, let's finish up the homework from last night that you're supposed to do. And then we will finish up 5-3 tomorrow and then get on to 5-5. All right, here it is. Remember how I told you I would do this guy? I would factor him first. This one's a kind of a pain in the butt. So we said that it would factor into x squared and x squared minus 25. And then what pops up right here? So I've got x squared, x minus 5, x plus 5. The reason I'm factoring is because I need my what's to be able to graph this. My roots. What are my x-intercepts on this one? How does this become 0? If x is 0, how does this become 0? Positive 5. How does this become 0? Now watch what happens here. There is something that's going to happen, and we have talked about this. I know that I've made this class tough, but it's because it's going to come up later on. Here's an example of something we've talked about. Hasn't come up in a little while, but we should be able to do it. I've graphed these. Negative 5, 0, and 5. And I'm not thinking too much, but I know that it's positive and I know that it's even. So I know that it should start up and end up. And I go to draw my graph, and I just start going, and I realize what? That doesn't work out quite the way it should have. Because I look back, and what happens with this root? It has a what? A multiplicity of 2. What happens at a multiplicity? This is the root of that. What happens at a multiplicity? It touches and it goes back down. So let's try that. Let's try. Do you see how I'm sure that most of you would just graph it, try it out, and realize, oh, that's not right. And then you need to look back and see why it's not right. And boom, it touches right there and then goes back down. So it looks something like that. With me? Now that's the shape of it. Now that I've got the shape of it, I need to be a little bit more specific. Where does this graph stop at? Or where does it start at? Starts when my x is what? Negative 2. Where does it stop? So I need to figure out where is that actual point at on the graph. So how can I do that? What can I do with negative 2? How can I actually figure out what the y is? Plug it in. Does everybody see I'm going to plug a -2 in and see where it goes to? I'm then going to plug a +2 in and see where it goes to so I can actually get a much better drawing of this shape. And I just need the beginning point and I need the end point. Everybody with me? So -2 to the 4th is a -2 times a -2, which is 4. And then what I do is here's how I do this. This is 4, this is 4. 4 times 4 is 16. That's how I do that problem. So I get a 16 here. Minus -2 squared is 4. 4 times 25 is 100. So this is a really big negative number. Does that make sense? So do you see how I can erase that half of the graph? I know that all that's going to show on this is it's going to look something like that.
Wait, but it's still up.
It eventually it's going to go back up, but remember, I only use this piece of it. I don't use the piece that goes back up. This is a piecewise function. I'm only using part of the graph. So I'm not using the part that hooks back up. Remember I said draw it really lightly with pencil because we're going to erase part of it? That's what I'm only using a piece of it. You with me? What happens if I plugged a 2 in here? Am I going to get anything different here?
No.
No? Am I going to get anything different here? So guess what this thing's going to do? That's all I'm going to see for this part. That's the piece that I'm going to see. And if I wanted to, I would draw that all the way down to 100 minus 16 is what? 84? I would draw this all the way down to 84, and at -84, I would have this going down, and would it be a bubbled, completely circled in, or would it be an open circle? It would be a circle bubbled in because that's where it equals. It's allowed to be equal to that, so it would actually be a colored circle in. Real quick, let me finish these last two. This right here, I want to change it to slope-intercept form. X plus what would still be x? 0. What would my slope be since this is a 1? 1 over 1. Everybody okay with that? So I'm going to use green to try to draw this. 0, 0. But do you see how I want to go to the -2 side? Do I want the right side of this graph? No, because I want... It only picks up where x is -2. So I need to go backwards. How do I change this to go backwards? -1 over -1. So I would go backwards. That means I go back 1, down 1, 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 and that's good enough. And this graph starts where x equals -2. So where x equals -2 is right here, so it picks up right there and goes on. Now there's one more thing, and this eraser is kind of hard, so bear with me if it marks it off. What I have to do is I have to realize that x is not allowed to use this graph when it's -2. When -2, I use this one. So how do I show that on my graph down here? Probably going to erase the whole thing. I have to erase that little dot. And I need to make it an open circle because that tells the person that is not where x equals -2. When x is -2, it's all the way down here because I use this equation. Remember, this is piecewise. We only use parts of each of these graphs. And the last one I need to do is this right here. And it says where x is greater than 2, this is always 2, which means you're just graphing y equals 2. Well, where does y equal 2? Be careful because they're going up by 2. Y equals 2 right here. But remember, that graph only picks up from here over. And again, it's not allowed to be equal to, so on this endpoint, I'm going to put an open circle to tell them that it does not use -2 or +2. It's 2 -84 because I use this function when I'm x equals 2. All right, we'll finish up 5.2 tomorrow, just a little bit of stuff, and then go into 5.5.